I can't explain how excited I am to be chatting to the sort of 2021 delegates of BYM. I've met a couple of your alumni. They certainly stand out in my mind. So it's an absolute honor to be talking to you today. So I've got a couple of objectives out of this talk. And the first is I'd like to share the journey of innovation that I've sort of been through with Data Profit. You know, we way back in the early single room days of Data Profit, you know, it was a young startup thinking month to month, you know, I'm going to make salaries to pay our staff, through to this organization that's bustling with literally bursting at the seams. And it has been a simple journey, and there's been a lot of lessons learned. So the first part of this talk is to share that journey with you, and how from the tip of South Africa we've been able to deliver value into the rest of the world and actually change it just a little bit. And then my second objective out of this talk is to equip you with a sense of what is necessary to bring the fourth industrial revolution to life in the world around you. And when we talk about this concept of the fourth industrial revolution, it involves things like robotic process automation, this great big thing called artificial intelligence. And it seems complicated and it seems difficult. And when we look at the world around us, we notice that the opportunities may not necessarily be that sophisticated. And I think that the word of reassurance is that the solution doesn't need to be that sophisticated either. And so that you don't need to leave the people behind. In fact, we can build them into the process and uplift folk, particularly in Africa, where it's so desperately needed, through to delivering solutions that can change the world. So, you know, if you walk away from this and when you're going down the streets in your hometowns and you can see something, be like, ha, there's a fourth industrial revolution opportunity, and we can go and develop it and see it, then this talk for me has been a success. And specifically to that end, if there are any questions during the talk, I'm quite happy to segue in and speak to some specifics there. I've got an eye on the chats, so please just do pop it in. And then I hope that we can have a really good session after the talk where we can unpack your specific details. So I think it's time to jump across to a presentation. And I think this is where a lot of the big fun starts. Folk, can you see my screen just to check in with? We can see your screen. Amazing, rad. Okay, so a little bit about Data Profit and why this all matters. And I think I'm just going to spend 2 seconds on this, but I've built up a team of sort of 40 plus folk. We're mostly based here in Cape Town. We have offices in America and have a corporation out of Amsterdam and Holland. And we've brought this thing called an expert execution system to life. And it's one of these great pieces of value add to the spectrum of the fourth industrial revolution. But the story starts out a little bit smaller than that. At the moment, when we think about what Data Profit is being able to provide, is installations, or we call these things deployments, literally around the world. So we have folk operating and using our service from Japan, through China, through India, particularly sort of Western Europe, Brazil, Mexico, and the US. And all of these folk are using this beautiful South African solution. And we did it here first. We did it with one set of guys called Atlantis Foundries first. And this is the journey that I would love to share with you. Now, a foundry is not a technically advanced thing at all. You know, I've gotten to know the CEO of Atlantis Foundries quite well. And way back when we were this very young business, he actually walked through into our offices. We didn't have an appointment. He just happened to be in the building. And he says, well, I've just had the worst scrap rate at my customer than ever before, and I'm on the bad supply list. So Atlantis Foundries actually casts these very big engine blocks that go into the Class A trucks that Daimler produces. And they have this sort of big foundry where they pour these engine blocks and they ship them off to Mannheim in Germany, as well as Detroit in the USA. And it takes about 8 weeks to get there. And as the CEO is so fond of saying, we've been working with molten metal since just after we started using stone tools. And so we should be able to understand it really well. But his engine blocks were arriving in Mannheim, where they did some further surface treatment. And they were discovering these kind of defects. So we have what's referred to here as an internal defect, that's this one here on the right, and an external defect, which is this very small one on the left. Now back at the operation down in Cape Town, where we're pouring this metal and we create this engine block, and we perform a visual inspection before the block is sent off to the customer. And the folk who are doing the visual inspection, it's not a very complicated technical test at all. It just requires one's eyes to be opened and some kind of recognition to occur, right? And by and large, it's really good. But the latent risk is when the part is machined in Mannheim some 8 weeks later, and we discover this sort of subsurface shrinkage void. And it was this problem that brought the CEO of Atlantis Foundries into my office. And he says, well, we've got this thing going. We've just shipped an entire container of our product to Mannheim, and it has arrived defective. I've had this huge penalty levied on my business, and it's just not good enough. I'm in trouble. I'm on the supplier. They've given me notice. They're going to replace me, and if I don't improve my quality, we're not going to get anywhere. So I'm very excited, very enthusiastic to get there. And I'm like, well, we're going to ingest all your process data. We're going to create a kind of predictor on the results. And we're going to solve your problem. And at this point, the sort of value add isn't quite apparent, what we actually going to do to improve the process. So we implement this predictor. As these engine blocks come off the line, we literally say good or bad. We use some very fancy technology, a deep learning network that actually isn't that complicated, but we're just giving this sort of metric of whether we think it's good enough or whether we don't think it's good enough on the subsurface defect. So I get a phone call about 3 weeks later from it's like, well, Mike, thank you for that. We haven't had a defective component arrive at our customer yet. So we've actually got 0 return scrap, which is from an average of about 5% that the supplier would accept. The chaos mode that got him to talk to me was about 20% rate. But now at the moment it was 0. So it was like, that's great. But as a side note, my internal scrap rate has gone up through the roof. It's the worst it's ever been in the 40 years of the history of Atlantis Foundries. And I think it was at that moment that there was a realization in me that the process hadn't changed. All I had done was I had augmented a guy who could inspect the exterior surface of the product and say it was good enough with some kind of data system that was providing a measure on the internal quality of the product. So it was kind of like X-ray eyes for the quality inspector. I hadn't improved, I hadn't fixed the actual process. In other words, it was still producing scrap items. The only thing that they weren't doing is they weren't shipping the scrap items. And this wasn't good enough for CEO. And so the point about not changing the process ran true. And I'm not sure if any of you have been up the West Coast, just outside Cape Town, but there are these beautiful canola fields, these big yellow flowers that occur just in the springtime. And I was driving out for a meeting there, and purely by accident, I had this idea on how we could put the system together. And it was just this problem that had been turning over in my mind. And respectfully, I canceled the meeting. I was like, I've got this concept I would love to run with you. You've got to give me a week. We're going to come back with something. And what we came back with was a very simple set of things for the folk who are operating these heavy machines to go and change. And there's no precision in these things, right? I mean, we're moving tons of more material. If there's 1 or 2 degrees Celsius difference, it really is not controllable. Folk are trying super hard. And this photo is interesting for me because while you've got the immediacy of the process here, you have the instructions for the changes sitting over here. Now, this guy is just trying not to burn himself alive. And you've got all these great things that he should be doing properly to go and improve the process. And there's this massive disconnect. And so we built this AI system to simply tell the operator, right now, the one thing you've got to go and do and change is this. Don't worry about everything else. The AI system will take care of it. But for you, sir, you've got to go and focus on getting the pouring profile, rise time, to a specific value. That's an example. For another guy in another part of the plant, we were like, well, you've got to go and hold the graphite content between this range and that range. Don't worry about anything else. Right now, the one thing I want you to focus on is that. And we got lucky here because what we managed to succeed in doing was match the sophistication of the actionable intelligence that we were generating with the immediacy of the information requirements of the folk who are doing the hard work. No complicated instruction sheet that needs to be read or understood, but really a very simple, right now, one thing you got to focus on, just this. And then I got a phone call from the CEO, and he was like, we have another problem. We're in trouble with Germany because we're no longer supplying any defective blocks. And it turns out that Daimler was using the arrival of defective components as a way of modulating the contract value, because these folk would turn back a penalty when a defective component would arrive. This is a part of being a tier one supplier to a very large automobile. And he says, that's generally not a problem, because what I would do to satisfy the customers is I would go and find a few defective blocks, mark them as defective, but ship them, satisfying the contractual requirements to ship at least 2% scrap. And I went to my stores and there was no scrap at all. A traditional gray iron foundry process that has an internal combined aggregate scrap rate in the order of 20%, and it was sitting at zero, absolute zero. And for me, that was quite a cool moment. And things started to change quite quickly from there. We started talking out to their foundry and talking out to their customers and talking out to the folk who sort of saw how this supplier had changed their position. They had gone from being on this red list under notice to being this crown jewel in the supplier list for Daimler. And we've gone out to many other folk with similar processes and achieved the same thing. But we did this thing wrong first, right? We were prepared to innovate, prepared to try. We had created this predictor. We had improved the quality gate. We hadn't improved the process. And in this moment of opportunity, we figured out we could go and change this one thing and had a bit of success. And it turns out that we managed to actually change the world a little bit at the same time. Because whenever you melt some molten metal, you use electricity to do this. And South Africa's Eskom recently has the dubious honor of being the most polluting power producer in the world, right? So we're number one, but it's the wrong number one. That's okay, we'll fix that too. But the bottom line is that the scrap, the fact that you would cast this component, you would have something defective to it, you'd be releasing tons of carbon dioxide equivalent emissions from the gas-powered stations, from the coal-fired power stations into the atmosphere. And in fact, you just waste it because you would have to remelt the cast block because it had some defect. So this small little change, right, taking it to a 0% scrap rate, saves between 1.9 kilotons and 3.8 kilotons of carbon dioxide a year. Now, I go and estimate my lifetime carbon emissions. It's about that. And that's one foundry. We've gone out, we've done this for folk in Spain, we've done this for folk in Brazil, done this for folk in the US, in China and Japan. And so a little bit less carbon dioxide released into the atmosphere as a result of an AI system telling somebody, here's one thing you've got to go and do. For me, that is just such a cool and exciting thing. So looking back on this, I've got a few more sort of things to talk about, specifically providing a sort of context for why it matters to do these things here in South Africa, and particularly Africa. And on the left, I'm going to use the COVID pandemic as a bit of an example, because I think it's quite relevant and quite important. On the left, we're looking at total infections. So the red dots are scaled by the total number of detected infections. Obviously, there's a whole bunch of sampling constraints to this. And on the right, we're looking at vaccines administered. There's a very symmetry between these points. And the big hole that sits is around the number of vaccines administered in Africa, given the number of infections. And so we sit in this moment where the world is poised to sort of return to some relaxed state of normality, and we all run around with our masks. We're not out in public with open faces, except for folk like Norway, where the entire set of restrictions has been relaxed. And then we've got to look at a little bit more of a dangerous number, right? The reason why it matters even more. We look at the case fatality ratio. What proportion of the measured of the detected folk who have COVID have actually passed away? We can talk to access to medical care. We can talk to detection efficacy, which is also another part, and there is this area in that data. But the thing here is in the top 50 list, the worst case fatality ratios, countries featured for more than half. Which means that there are good folk, breadwinners, family members in Africa who are dying who don't need to, because access to vaccines is not available. It's a very sombering thought. And the fourth industrial revolution, improving the lives around us, is the call to action, I think, for all of us. The opportunity that exists can go and change the world just a little bit. And the aggregate effect of doing it really, really matters. It matters even more doing it in Africa. So with that little somber comment, I'm going to sort of go on and sort of explain how I see the world a little bit. And I'd like to start with the sustainability maturity path. This is a bunch of work that was put together by PwC almost a decade ago. And they looked at the phases that companies can go through and how sustainable they are for the future. In other words, do we expect this business to stick around for the next 20 years? And so at the bottom of this, we think of folk who are operating in a value protection mode. They've got a business model and they don't want to change it, right? They have some expectation of compliance, that they do what they do because they've got to do it. And for them, their commercial existence is purely around reducing operational and compliance risk. And if we think about what this means, and I must apologize to folk in the rest of Africa, these examples are very specific to South Africa. I'm sure that there are analogies in your countries. I'm just not aware of the specifics of them, but I'm happy to unpack it. But here we have things like called regulators, and regulators are really the watchmen who make sure that you're doing things to the minimal acceptable standards. For example, we have the rail safety regulator, who describes the maximum gap between a rail car and a platform, which means that people don't fall into the gap between a rail car and a platform, which is often fatal, right? And so we have 14 of these folks. We have an energy regulator who looks at emissions, and they're sort of just there to keep folk in line, and the folk who are doing things are just there to comply with those rules. At the next step up, we look at these monopolies. These are typically folk who are governed by regulators. And here there's an obligation for them to provide a service. If they don't, their reputation goes to poo. We have an example of that in terms of our power supplier. They have some license to operate, which gives them the right to be a monopoly. And there's this sort of thing that they've got to do, and their whole existence is around not appearing to be too awful. It's a terrible thing to say, but it's the only way in which they can protect their value. They're not changing, right? There's no sort of innovation that sits under them. Their daily existence is about minimizing reputational damage. Then the next level up, we find these listed entities. These are folk who trade publicly. They've generally got to be profit-making. We heard yesterday from a colleague of mine how tricky it is to be in a loss-making listed entity. It does happen. It's absolutely terrifying. It sounds awful. But for them, their existence is about taking a value proposition, not changing it, but making it a little bit bigger, which is this value growth. And for the way that they look at it, it's operational cost savings. Really what this means is good financial management, where you just sort of turn the screws down on frivolous spending, for example, and is value cost savings. So you can go to your suppliers and renegotiate a contract, or you could look for some cheaper supplier, an alternative source of some material. But really the day-to-day work is about taking the existing value proposition, making it a little bit better. And that's traditionally what these businesses do. They've got it, it's well established, and it works quite well. And then we have this other space, this sort of leadership where there's new value creation. And value creation is super exciting because you've innovated, you've made something new, you've got to bring it out to the market, you've got a new way of doing business. And if we think about what the startups of today are building, it's really what are going to become the company, the bigger companies And so therefore, they, on the sort of mature sustainability path, the young company happens to be more mature because the model that they're innovating is probably has a longer life into the future than, say, the folk who are operating in compliance level. So this is the good work by PwC. And I sat back and I looked at it and I thought, well, maybe there's a way in which these companies look at data and particularly how they use it to drive their decision. So when you sit in a value protection mode, do you use data in a different way when you're in a value growth mode? And do you use that data differently in a value creation mode? And in my opinion, we do. So I got this mapping now. So I can map the way in which data is used to a compliance route. So this is the data profit extension on that work. So when there is compliance, data is used for control. You've got policies, you've got procedures. And so everything digital, everything that drives these systems is run by data into gate functions. Is it acceptable? Am I below a critical threshold? And is there any kind of deviation that I can expect? And this is deeply dependent on human judgment to choose the correct gate function, to find the right threshold, and to codify the digital process that represents the physical process. So it's a very interesting point where there's this like minimum sufficiency of the data to drive the control over a process. In the license to operate and the obligation, as well as an expectation to do, typically you find command, which is different to control. Command is where you sort of give an instruction. And here dashboards are creating a sense of a visual device to create an intuitive sense of progress. So you've got to create a graph, a bar chart, a kind of refill monitor, some kind of visual component, a little widget that says when you look at it up, it's trending upwards or it's trending downwards. And so these commands typically drive the cost management or the business metric monitoring. You'll find them in a lot of these folk places. When you walk through the door, there'll be a big dashboard above the reception area. It gives everyone sight onto this one thing that is so important, but nobody actually knows how to change. In these other listed entities, when we sort of think about what operational cost savings are, here, data is used to drive the business process. So you've got this input, maybe it's a stock level, and the stock level drops below a threshold, which can then trigger a series of actions automatically. Although you often find that there's a lot of user oversight, and the system can generate its own inputs, and so it could automatically place an order for more stock if necessary. And then we find right up here on the sort of further end of this on the AI spectrum, we find these innovation systems driven by machine learning, where you've got these autonomous systems that adapt to change and sort of speak a little bit more to the points of automatic innovation. So I'm just going to quickly read a question here, which comes from Moketi, which is about how does this path differ from sort of Western countries to African countries, or companies in Africa, or commercial relationship in Africa to where it is in the rest of the world. I've had the privilege of presenting this sort of thinking to folk in Japan, which I would argue are highly industrialized, and I've had presentations to folk down in KwaZulu-Natal, which is a very manual process where there wasn't a lot of data. And the one really exciting point for me that came out of that was that the aspects of the business sit in these different silos. And so you can have an R&D department in a very mature sort of value protection company, where as the brainchild CEO or some executive sponsor has actually built an R&D department to drive some kind of innovation. And so it's not necessarily a single box that you put an entire company into, but more a mindset for the way that a specific department can run. And I have seen the entire spectrum in Japanese companies, and I've seen the entire spectrum in South African companies. So I think it's a great question, but I think that the framework is quite abstract. You can apply it broadly, and therefore it holds true. Right. This is the next very difficult thing. This is a survey of adult skills in ICT problem solving. So using a computer to solve a specific problem with different levels of complexity. And so we describe these sort of 4 levels, right? So you've got this sort of, in fact, there's one missing. So we have level 5, level 4, level 3, level 2, and level 1. Now, level 1 are folk who are illiterate. So of the portion of the population, the missing portion is the illiterate. We centered this score on 0. The specific task that a level 5 person solves is find the email that I sent you last week, Tuesday, and adjust the numbers to reflect the values for today. And this is an important task because what's necessary is you've got to find some information in one application, understand the request, move it to another application. So it's a context switch. Transform that data in some way. It's not a very complex transform at all. And then take this result back and reply it on the original application. And so that is something that probably we are doing hundreds of times in a day, right? We find here that the folk in New Zealand, so the label dropped off, New Zealand leads this. There's the largest proportion of their population can actually handle, out of OECD member countries, can do this task. And then we move to simpler ones. This is just a simple search. This is in fact just reading an email. These are folk who are able to open an application, and the rest of the population can't do this. And so to be functionally literate, we need some kind of score above 0, and to be proficient, we need to sit here. And the reason why this is important is because it demonstrates the spectrum of ICT skills across the world. Because if you've got to go and do this very complicated transform, and the folk who need to do it can't do it, you've got this great solution, but there's a mismatch between the solution complexity and the consumer, the person who needs to do it, their abilities. And I find that particularly like looking at Turkey, just how large a proportion of their population is in fact functionally illiterate, cannot even find the power button to turn the computer on. And then we want to try and use the 4th industrial revolution to change their lives. We've got a little bit of a problem. Right, so the takeaway from this slide is match the solution complexity to the problem complexity. And that's an important one. Then I think I want to take a moment just to look back at the Gartner hype cycle of 5 years ago. And the reason why 5 years matters is because it means that we get to look at these things and say, how did these predictions ring true? Was there any sort of good truth or value in this? Now, what Gartner does is they define this hype cycle as something that starts at an innovation trigger, then the marketing team gets hold of it, and they sell it to the world, and these guys are really good because the expectation on the delivery of the technology shoots right up to the peak of inflated expectations. And then us engineers are sitting there trying to deliver these cool things, which are quite tricky. And the customer's like, well, in fact, this isn't what I was promised. We end up in this trough of disillusionment. And as engineers get our act together and we start delivering things, and we end up on the slope of enlightenment where the expectations start matching out of the technology, and then the mature technology sits there at this plateau of productivity. So it's a great little thing to look at. And what Gartner does is they go and look at these different technologies and they say, we believe it'll be realized, in other words, on the plateau of productivity in some duration. So we can go back and look, and we see this cognitive expert advisors, and I've put a big dot on that because I think it's an important point about what an expert is, and I'm going to unpack that on the next slide. But we were saying, well, could these things do really well? And in fact, the world was saying at that stage, in 5 to 10 years, we think it'll get there, but it's really got to get quite poor right now. As a little bit of a joke, who would have thought that 5 years ago we were looking at a pandemic? Yeah? It's quite a thing. Today, digital twins are commonplace. And added a lot of value at the engineering level, but not a lot at the process improvement level. Edge computing is commonplace, which was quite quickly achieved. Deep learning is everywhere on our mobile phones and our online ordering. And things here like blockchain are moving between these points backwards and forwards. So just to take another second to ask, there's a question here from Marcia around given the work that I do I have the space to inform or advise policymakers given the practical work we do in relation to fourth industrial revolution technologies? And the thing that I'm the most proud about is our contribution to the World Economic Forum as a technology pioneer. So we are actually setting a little bit of the agenda in those conversations there, predominantly about using our technology for good, to change the world, to minimize carbon emissions, to maximize value, and to create these sort of greater competitive results that can make let African operations play on the world stage. Right, okay, back to expert advisors. And I think that let's start off with what an expert is, an expert means, or it means to be an expert. And I think that the point of recollection here, and these are the folk when you're out in the world, you can spot them. The phrase silver fox is the best descriptor. These are the guys who have been running a process for ages. This is, for example, Lawrence's uncle in that dryer in the video that we saw earlier. This is the guy who's seen it all. He knows how the thing works, and he's got a little bit of magic that he's able to run on the process. It's predominantly underpinned by a little bit of knowledge from an education. He got lucky to get into that position, and then they've just sat there building up experience over time. And as a result of this, experts are inherently rare, and they're inherently very hard to move between domains. And so you've got this shortage and cost of experts, which means you can't move their knowledge from one space to the other. If we think about this, what this means in the space of boundaries, for example, if we observe a specific surface defect, then the expert says, go and check a value for me, go look at value X. If it's too low, go and increase quantity Z, or if it's too high, go and reduce quantity Y. And that, just that expert knowledge to go and say, what is that one thing we've got to go and change, is very hard to get and improve the process. And if it's lacking in an industry, you find that these businesses start floundering, the cost of doing business increases, and it's really the thing that the fourth industrial revolution can have a significant impact upon. And so let's talk about the human in the loop. I hear this phrase quite a lot, and there's in fact a fallacy behind it. So what I'm showing here is where you have some kind of production machine going to the human in the loop, who then codifies their input into some kind of dashboard or set of instructions that a bunch of operators must blindly apply back on the machine. And often folk will say, when you come up with a artificial intelligence solution that wants to go and change or control the process autonomously, there's a lot of concern. They're like, can't I put somebody there? Or another example, which in fact was a little bit more egregious, was where there was a business that was offering one of these Amazon Go-like services. Now, what Amazon Go is where you have a bunch of video cameras watching a storefront. You walk in with some kind of identifying tag. You can pick up whatever you want on the shelf, and as you walk out, you are automatically billed for it. So there's no need for a cashier. But the problem there is that you've got to track this object that's gone off the shelf and into your bag. And it's a very hard machine learning problem to solve robustly. And so what this firm did, instead of actually solving it, they said, we've put humans in the loop. And the truth behind their solution is that they just have operators watching video streams, automatically adding things or removing things from a basket. And in my mind, that's cheating. And I think that that is where the fallacy behind real AI and human in the loop sits. As soon as you have this component, where does the actual value sit? In the case of the Amazon Go type service, these guys have just made a remote cashier service. They actually haven't made an AI-powered service at all. And so how we do it, very importantly, very different. We take machine data, put it into our AI system, and we let it apply itself back onto the machine. We can generate these insights, we can generate results that can help the operators understand what's going on in the machine, but we're no longer generating very simple instructions that these folk must just follow. And this is in fact a very subtle empowerment play, because what we've done is we've empowered these folk to understand what matters now and why. We've taken that human in the loop out deliberately and we've empowered the users of the service to understand things a little bit better. So now quickly just up, I see I've got about 5 minutes left in this thing. I'm going to present a little roadmap for your journey. What are the things that you can watch out for when you look at the world around you to bring the fourth industrial revolution to life in another space in our world? Because if we can do this, we can really transform the operations here in Africa to deliver great value to the rest of the world. So I think we've got to start by digitizing, right? And digitizing doesn't mean digitize everything, but we do need to digitize enough. So I'm going to talk to how much data you actually need to make this change, to understand what you need to measure, what kind of structure do you need so that you can bring AI along. You don't need to bring AI into the very first step. I'm going to tell you why real-time actually doesn't matter. I'm going to talk to how we can improve quality data and where to place sensors in systems so we can have a sense for where the process is deviating. So this is an interesting one, a very simple process of welding. Welding is literally described by 3 parameters. You have amount of current that you apply, for duration that you apply, for how long, or the physical movement when you press the weld point in. Just those 3 parameters can describe an individual weld. And this is a weld at this station, and this is a weld at that station, and the results could be a defect, for example, a burn through where you've put too much current in, or you've had the weld duration was too long. And so the number of sensors to bring a process to life in this regard is minimal. It's 3 things. It's a current measurement, it's a timer, and it's a position measurement. Very simple sensors to go and put in, not a complicated technical solution. But the one thing you do need is you need a sense of where the quality gate sits. And so you've got to make this causal relationship between the things that you are measuring and the result that you are ascribing to it. So that's the one thing that you've got to keep in mind. And then we've got to talk about how much history we need to actually train a service on. And typically 1,500 observations is more than enough to get this alive and running, which also means it's maybe a day's worth of production you learn to the underlying system. And that speaks to the strength and power of the techniques that we're using, but also just the versatility of this approach. I think the other thing that folk think about is that whatever the underlying process is, it's complicated. We've got to bring in a process engineer. We've got to bring in these experts who can solve for these very complicated set of equations and mass flow. And the reality is that it's just a simple set of transforms. Know when one thing is in process 1, another thing is in process 2, and describe it as a batch. We call this little structure a unified view, and it's quite a simple thing to produce. If it's continuous manufacturing, we look at material flow. But if there is discrete or batch manufacturing, you can just track a simple serial number. You don't need to go and build complicated mass flow models, anything like that. But it's a fascinating thing just to structure, just to say, well, when I record the data, what are the things that I'm going to be associating with? Am I recording with respect to time, or am I recording with respect to batch? All right. I think this is the next big thing when we build these fourth industrial revolution systems. Well, the first thing is we start putting in a lot of ICT equipment because we want the results quickly, and we want it to be live. And so we try and reduce latency, we maximize bandwidth, which is really good if you're sitting close to an internet backbone, sort of in San Francisco, you've got gigabit fiber to every point in the building. But there's a cost associated to that, and it's not the reality of the world. And so here, as soon as you move into this super quick paradigm, the response to a defect or some deviation of the process shifts from the digital system to how quickly the user can go and implement a change. And so you're still fundamentally reactive. Something changes, you know about it really quickly, but you've got to go and fix it before it actually has a defective approach or produces a defect, sorry. There's a subtle change to the paradigm here that we can use. We say, given that data may come in late, let's not worry about when something goes out of spec. Let's make sure it never goes out of spec by making a small corrective action now, well ahead of any reactive or necessary reactive response, right? So you can apply this action, apply this correction in advance of the defect, and this is how you could get to 0. If you were super reactive, you would have to have a defect rate that was within 0, because you'd have to be reacting all the time. But it would be quite small if you could react quick enough. And I think that the other thing we've got to do, which isn't done very well all over the world, this is something just a personal point, is that we've got to record the results a bit better, either at a manual station or at some kind of automated station. But bringing this back to the dryer that we saw earlier, things like how long something was in the kiln matter when the results of what is in the kiln are recorded. And if you're not able to connect those two bits together, we've got a challenge. And so it's a very simple piece of advice where we ask, when you run your process, record the results in a way that we can connect that result to the state that the system was in ahead of it. It seems like an obvious thing, but it turns out for a lot of folk it isn't. So bear that in mind, and that just this change alone can start helping process improvement drastically. This is now a super detailed, super cool view of an internal layer of a deep learned system. I don't want you to worry too much about that, other than to look at the fact that the variation in color in this highlighted region is in fact quite poor. And this is where we can start using AI to make the AI better. And so what we're actually describing in the lack of variation of the color is the fact that there is a sensor missing. Something that describes differences is missing from something that should be there. We are able to locate that or localize where the deficiency is with great precision. And so you can say, well, in fact, now I need to add an additional metric being external humidity when we're running this dryer, because that can affect or have a meaningful impact on how long the dryer should be operating. So folks, these are the sort of like Mike's 5 rules for the industrial revolution, for making it real. You know, typically a few thousand measurements over tens of process parameters. You've got to get your traceability right. You've got to shift your paradigm from trying to put the burning platform out to one where you're ahead of the defect occurring. You've got to connect the quality data or the result data a bit better to your process, but you can drive that with some kind of automation. And then you can use the system to improve the system further. And with that, folk, that's me. Thank you very much for listening, and I'm really excited to dig into some of the questions.
Great, thanks, Matthew. We've got some questions in the Q&A box, and happy for you to take a few and answer them at the time. Yeah, thank you. It was a great presentation. Okay, so one from Kenneth Diole, which is, how do we reconcile the developmental progress of the fourth industrial revolution in relation to the stark, livid reality of millions of people in South Africa and Africa at large who are still to experience the benefits from earlier industrial periods? Lack of electricity, use of pit latrines, vast unemployment, means that energy is focused on survival and not sort of development. And this is a very good point. And thanks for raising it, Kenneth. So I think that the big learning for me out of all of this has been that you don't have to go through the steps 1, 2, 3 to 4. And this we did at Atlantis as well, where maybe by the definition, we were sitting somewhere in the second 2.5 industrial revolution. And we were able to uplift the operators. Remember, we made this service, made this change to help folk do their jobs a little bit better. Nobody wants to do a bad job, but if you can guide folk on how to be a little bit better and minimize that sort of noise or the need to filter out noise that comes from these adjacent information sources, then you help someone significantly. But this doesn't necessarily address the folk who are unemployed and sitting desperately seeking some source of income to sustain their families. And I think this speaks to the fact that you need a result, second order effect from providing a change to the process that then can trickle through to or contribute to the rest of society.
In other words, we need South African manufacturing to work to create more jobs, to create opportunities for those folk. We make more jobs by increasing demand for really good product. And so the way that I see it is where AI does not replace people. It augments them. It's not human in the loop, but it helps the job get better, right? So I'm just going to mark that one as I have a lovely question here from Ketty around, in my experience, is our education system producing skilled people to take on the work? Is this a challenge? And how does the skill pool look like? I'm going to tell you a bit about my colleagues. They're some of the most amazing people. I have the greatest privilege of working with these folk. They are exclusively educated inside South Africa. And they are the most innovative, intelligent folk. And when you give them opportunities to invent new things, they invent multiple of new things. And what matters more is the culture of innovation. And in our previous speaker, welcoming one, which was said, don't be afraid to fail. I think if you can remove the sting of failure, you'll find a lot more innovation blooming out of these opportunities. I find, being a small business owner myself, data profit, it's quite a thing to run a business, right? I certainly couldn't do it alone. I have the most incredible co-owners and co-managers with me, right? And these folk have to fight a system to make this business live. And it's really exciting the fact we get to do that, but there could be a lot of more assistance in terms of deregulation for the things that we've got to go and solve for. So from Rajiv, how do I see the workforce changing in the next 10 years with the implementation of machine learning and AI? So what I see changing is that folk rely on the outputs of machine learning and AI systems more and more and more. It becomes sort of pervasive in daily life, but I don't see the workforce changing drastically. I think the workforce becomes more competitive because we can produce a better quality product at a globally competitive rate by using this this thing to augment and contribute rather than replace and drive. Again, if you take a negative view on folk where you drop out of the, you say, well, we're going to use AI and robotics to replace people, I don't think you get there, but I don't believe that you need to approach the problem from that perspective. Another one from Rajiv, which is, if I can tell the youth of today what they should study now to remain relevant in 2030, what should they study? And I could only be able to answer that question in 2029 because the world is changing that fast. And I think the most important thing is be curious. Throughout my life, this is the one cool privilege I've had the chance to do, is to go away and think about problems and sort of see what's underneath the surface and tease out the things that are yet seen. And just a sense of curiosity, of critical thinking and curiosity is far more important than any one specific knowledge. So the relevance in 2030 will be determined in 2029, probably December 25 to 27. But broadly, I'm a fan of the STEM fields, but respect and appreciate the contributions of literature and art as well. Can't be overly prescriptive on anything like that. From Mohammed Alpha, where can we start as a continent in AI, looking at the challenges we're going through? I think we've started already. I see such wonderful, exciting things coming out of Nigeria, coming out of Ghana. There's the folk like Africarena who have a beautiful view across these sort of innovators throughout our continent, and it is happening everywhere. The education exists, the access to the material is easier than ever before with the internet. There are free AI courses that, when you get through them, will make you as good as a computer science graduate from university. You've just got to have the tenacity to get through a pretty hard course, but there's not a cost barrier anymore. And so as a continent, we've started. We've just got to keep going. We've got to create the sense of ability that we can do it, create the access for folk to these resources so that they can engage their curiosity and explore these opportunities. Yeah. And I think think that I have worked through all the questions. Have I missed any, folk? Oh, there we go. There's another one. Oh, no, got that. Okay, there's an interesting comment in the chat around concern about our not so transformed education system and what the role the African Lions should play in developing this in order to lead this change. And education is something that is very close to my heart. For more than a decade, I was an honorary lecturer to the University of Witwatersrand because I believe deeply that to uplift and change the world, we must start with educating folk. But I don't think that it is a technical barrier. It is calling for educators in South Africa and Africa and the world to keep doing the great work that they are doing, and just to help a few more folk get through the process. I understand the pressures and stress on families so that we recall kids back from school early so they contribute to the sustenance of a family. And it's a sacrifice, and it's one that has profound ramifications to where folk will end up. And education must improve, but I don't think that it's one that needs drastic disruption. I think it's one that requires delivery of textbooks, delivery of resources to teachers, teachers to show up to their classes on time and deliver the coursework. That's just my view. Let's just see if there are any furthers. Yeah. From Courtney, in my opinion, has the pandemic hindered or accelerated the revolution? It's absolutely accelerated it. I'm busier today than ever before. And these are folk who are looking to reinvigorate their supply lines quicker as a result of the sort of drain out of the logistics network that the pandemic caused. We've shut down supply chains, now got to restock them quicker. And folk are looking for any kind of technology that supports this, both here and abroad. So it's definitely accelerated. And in my mind, it's gone very well. Yeah. Good. Folk, I think I've worked through that list. Zunaid and Elizabeth, are there any furthers from your side?
I've cross-checked, Michael, and I think you have worked through the list and very insightful answers. A very detailed presentation with a lot of data to show us and explain. And I think that that's been great. The way you sort of the course of your presentation was really easy to follow for something that is quite technical, and just your sort of experiences with data profits, particularly in the supply chain, in the sort of engines that had defects. That was interesting to see as well, and hear about how you use data and sort of really particular pinpoints in the supply chain and manufacturing process to mitigate those types of risks, to the point where your client says, well, I don't have any more defects now, and I need to show some, I need to send through some defective parts to Germany so that they can charge penalties on them. I mean, so that's just brilliant. And it's great to see South African startups doing such amazing things across the world. And even your work with the World Economic Forum, that's also exciting to see. And how, you know, it may not have been at the forefront of your sort of solutioning when you were creating these solutions in these engine furnaces, but really trying to, you know, actually creating a decrease in carbon emissions, because, you know, and that's gone to ESG now. So, you know, companies that are looking at ESG positioning actually can say, well, I've got data profits and they've helped us decrease our emissions by X amount. And that's just a win for efficiency, win for efficacy, and a win for the environment. So really, congratulations.
We look at these sort of science-driven targets, the STT stuff, and this speaks right in on that. It's you know, we see folk, particularly in Europe, who are under these incredibly stringent emission targets that they've got to go and reach. And it's driving the change, yeah. Oh man, we have a lot of fun.
Yeah, great. And I think a lot of comments coming through to say that this is a really great session. So thank you again. And any final comments from you, Michael, before we then move on? You're 2 minutes to time. So any final comments to the delegation?
Sorry?
Any final comments to the delegation?
Just my thanks and appreciation for listening to me. And you can always hit me up, mike@dataprofit.com. And I'd love to chat to you and see what we can do together.
Thank you, Michael. And as a WITS alum myself, it's just inspiring to see people doing amazing things from the university. So thanks for that. And yeah, hopefully a lot of delegates will be in touch with Michael and see where the opportunities lie.
Awesome. Thank you again. Take care and stay safe.
Take care.